Dear students, in this video lecture, we are going to learn how to solve a linear programming problem using revised simplex method. Revised simplex method is slightly different from simplex method. To understand this more better, it will be more convenient when you understand simplex method first and then follow this video lecture. Here we have the computational procedure to solve a linear programming problem using revised simplex method. So this computational procedure I will explain you along with the problem by solving step by step. Now here we have a problem under revised simplex method. The question is, use the revised simplex method to solve the linear programming problem given by max z equal to 6x1 minus 2x2 plus 3x3 subject to the constraints 2x1 minus x2 plus 2x3 less than or equal to 2 and x1 plus 4x3 less than or equal to 4, where x1, x2 and x3 are greater than or equal to 0. The variables x1, x2, x3 are known as non-basic variables. Now, here the question is a maximization problem. So, whenever you have a maximization problem, you can solve it directly, that is, as it is. But if you have a minimization problem, then you have to first convert it into a maximization problem and then solve it. Such kind of problem we will see in our future videos. Now here we have the constraints, two constraints, which means there will be two basic variables for this equation. But another thing what we have to check is the inequalities. So if you see, the first constraint has the inequality lesser than or equal to, and the second constraint also has an inequality lesser than or equal to, which means in order to convert this problem into a standard LPP, we have to add slack variables to both the constraints. So, to when we add the slack variables, the inequalities turn to be equalities. Whenever you have constraints greater than or equal to, you will have to subtract surplus variables and add artificial variables. We will see such problem in our future videos. As of now, since both the constraints are lesser than or equal to, we have to add slack variables in order to convert the given LPP into a standard form. So that is the first step. So the first step is to convert the LPP into the standard form. So we shall convert the given LPP to the standard form. So as I told you, I have written here, convert the LPP into standard form, introduce the non-negative slack variables S1 and S2. So there are two slack variables because we have two constraints over here. So therefore the standard form of the LPP will be converted as, now this max Z, so max Z will be equal to, so max z will be equal to, what is the given objective function? This. So we shall first take and write that. So 6x1 minus 2x2 plus 3x3. Now we are adding two slack variables. So both has to be added with coefficient 0 in the objective function. So 0s1 plus 0s2. Next, subject to the constraints. So subject to the constraints. The first constraint is 2x1. So we shall take and write that 2x1 minus x2 and then plus 2x3. So plus 2x3, and in the first constraint we have to add slack variable s1 with coefficient 1 and slack variable s2 with coefficient 0. That is, we are adding only slack variable s1, and so that the coefficient of s2 will be 0. So this will be equal to the right hand side. Now the inequality becomes the equality. Since the left hand side was lesser, when we added s1, the quantity s1, it has become equal. Similarly, the second constraint, what is the second constraint we have? This one. So x1 plus 4x3. So x1 plus 4x3, which means the coefficient of x2 is 0 over here. So 0x2 plus 4x3. So x1 plus 4x3, and here we have to add slack variable s1 with coefficient 0 and the slack variable s2 with coefficient 1, and that is equal to, the right hand side is 4. So we have 4 over here. So after this, we have to write all the basic and non-basic variables inequality, that is x1, x2, x3. All these are non-basic variables, and the slack variables which we have introduced, s1 and s2, are basic variables and all are non-negative, so that is greater than or equal to 0. So therefore, first step we have completed. We have converted the given LPP into a standard form. Next, we will move on to step 2. So, what is step 2 here? Obtain an initial basic feasible solution with an initial basis b equal to Im. So, let us see how to do this. The initial basic feasible solution is obtained by putting x1 equal to x2 equal to x3, all three values to be equal to 0. So what do we get? In the first constraint, if you put x1, x2, x3 0, we see that the value of s1 is equal to 2. And in the second constraint, when we put x1, x2, x3 as 0, we see that the value of s2 is equal to 4. So this gives us the initial basic feasible solution. We shall now find the initial basis. So what is the initial basis? The initial basis is capital B, that is equal to identity matrix IM. So what is this M? M represents the number of slack variables that we have added. So how many slack variables we have added? Two slack variables. So the value, that is B, will be equal to I2. Identity matrix with 2 rows and 2 columns. So we shall write that. So B is equal to IM. M represents the number of slack variables, so that's equal to I2. So what will be B? The matrix B will be equal to identity matrix. So 1 0 0 1. So from this, if B is an identity matrix, then its inverse will also be the same. So B inverse will be equal to again 1 0 0 1. So we have obtained the matrix B and B inverse. The next step is third step, that is state the objective function z equal to cx subject to ax equal to b and obtain the values of a, b, c, a cap, b cap, cb. So let us see this step. So in order to write the objective function in this form, we have to write the given problem in the matrix form. So let us do that. So if you see here, we have written the matrix form of the given LPP, max z equal to cx. So what is that cost matrix? It is the coefficients of the basic and the non-basic variables, that is 6 minus 2 3 0 0. So that we have written, and then x1 x2 x3 and then s1 s2 we have written in the column format. So when we multiply, we get this matrix subject to ax equal to b. So a is this matrix, that is here 2 minus 1 2 1 0 1 0 4 0 1. So that is the matrix A, and we know that this is the matrix X. So when these two matrices are multiplied, we get this constraint where the right hand side is the matrix small b. So this is small b, that is Ax equal to b. So this is the cost matrix C, this is the matrix A, this is X, and this is b. These matrices will remain the same throughout the problem. So the obtained values I have taken and I have written here. Now using these values, we have to find A cap and B cap, that is capital A cap, which is given by the matrix A minus C. So first we shall find this. So we have here A cap, which is equal to the matrix A and minus C, and that is equal to, first we shall write the matrix A as it is. So it will be 2 minus 1 2 1 0, and here we have 1 0 4 0 1, and followed by the matrix C where we have a negative sign. So multiply this matrix with minus, so it will be minus 6. So minus 6, minus into minus will become plus, so 2 minus 3 0 0. So this gives us the matrix A cap. Next we have to find B cap. B cap inverse is given by the matrix B0. So let us write that. So B cap is equal to the matrix B and 0. So what is the matrix B? The matrix B is 2 4, and so we will be having B cap to be equal to, so from this B cap is equal to, B is 2, 4, and we have this 0. So this is matrix B cap. All these matrices, that is A cap, B cap, and the matrices that we found previously, all will remain the same throughout the problem. The next step is, after finding A cap and B cap, we shall also write CB. So what is CB? So CB gives us the matrix, that is CB is equal to the matrix where we will have the cost of slack variables in the objective function. So what is this cost of slack variables in the objective function? 0, 0. So therefore there are two slack variables, and so that we will be having the matrix as 0, 0. So this is the matrix CB. Now, after finding the matrix CB, we will go to the next step. Here you can see that we have to find the value of B cap inverse, and this B cap inverse is not the same throughout the problem. So remember that it is recursive. For every iteration, we will be finding the current B cap inverse. Remaining all matrices that we have found previously will remain the same throughout the problem, but this B cap inverse keeps on changing according to the iterations, and we will be utilizing the current B cap inverse that we have in the problem. So here first we are going to find the initial B cap inverse. So let us do that. So what is B cap inverse given as? Matrix B inverse CB B inverse 0, 1. So we already found B inverse, and now we have to find CB B inverse and then substitute over here. So let us see that. So now in order to find B cap inverse, first we should find CB B inverse. We know that B inverse is 1, 0, 0, 1, and CB is what? 0, 0. So from this we can write CB B inverse. So we should multiply these two matrices, and that will be equal to 0, 0 multiplied with B inverse is 1, 0, 0, 1. We know that any matrix, when multiplied with the identity matrix, the matrix is going to remain the same, and so therefore CB B inverse will be equal to 0, 0. Now using this we can find B cap inverse. So I've taken and I've written B cap inverse over here. So B cap inverse will be equal to the matrix. So first is B inverse. What is B inverse? We know that it is 1, 0, 0, 1. So we can write that 1, 0, 0, 1. And then here we have CB B inverse. So that matrix just now we found. So it is 0, 0. So it is 0, 0. And correspondingly we have a 1 over here, so that we have to write. And how much ever rows you have here, you have to fill it with 0. So this 0 means the number of rows that are available over here has to be filled with 0. So initially always remember, the first initial B cap inverse will be the identity matrix. So this is the identity matrix, but it will keep on changing according to the iterations. So all these steps you can either do in the first initial stage, or you can directly write the B cap inverse identity matrix also in order to consume time. So next we shall move on to next step. So step 5, that is to compute the net evaluation. We have to find Zj minus Cj, which is equal to CB B inverse matrix CB B inverse 1 multiplied with the matrix A cap. So here I have taken and written this. Now so Zj minus Cj will be equal to. Now I will give you a trick, that is CB B inverse will be the last row of B cap inverse. Now what is the last row of B cap inverse? It is 0, 0, 1. So you can directly take and write that. So 0, 0, 1. And then we have this 1 over here. Including that one is this matrix. So this will not be there. That is, remember, CB B inverse will be CB B inverse 1. So this matrix is equal to the last row of B cap inverse. That is the current B cap inverse. So here the current B cap inverse is 0. The last row is 0, 0, 1. So it will be 0, 0, 1. So that is only including the 0. So CB B inverse 1. So this matrix is the last row of B cap inverse, which is 0, 0, 1. So that we have taken and written, and we have to multiply this matrix with A cap. So what is A cap? A cap we have found here previously. So take and substitute this matrix. So this matrix we will substitute there. So therefore, I have written the matrix A cap over here. Now we have to multiply these two matrices. We have to perform matrix multiplication. So first row, first column. So 2 into 0, 0 into 1 plus 1 into 6, which will give us minus 6. It will be a row matrix, so we need not write this big. So it will be a row matrix for minus 6. And here 0, 0 and 2. And then again 0, 0, so minus 3, and then 0, 0, so 0, 0. So this is the matrix Zj minus Cj. So after computing Zj minus Cj, if we look into the procedure, okay, we have two cases over here. So if all Zj minus Cj is greater than or equal to 0, then the current basic feasible solution is the optimal solution. So if we check here, we have to check whether all Zj minus Cj are greater than or equal to 0. But if we see no, we have two negative values. So it is not, we have no negative values, because of that it's not greater than 0. So we can move on to case 2. Case 2 says that if at least one Zj minus Cj is lesser than 0, find the most negative zk minus ck. So then the variable xk enters the basis. So we have to see what is the most negative of all these values. So if we check, minus 6 is the most negative, and we know that it is corresponding to the variable x1, because this is x1, x2, x3, s1, s2 as per the matrix a cap we had. So this matrix was for x1, x2, x3, s1, s2. So similarly here also we have this. So minus 6 is the most negative, and it corresponds to the column, which is first column, that is x1. So since minus 6 is the most negative, x1 enters the table. So from this we get x1 enters the basis. We know that the basis capital B is equal to what? S1, S2. Now we know that x1 enters the basis, but at which position it enters we don't know. That is S1 or S2. So that we have to find out. Next we will move on to step 6. So we have to compute xk cap, which is equal to b cap inverse ak cap. So first let us compute this and we will come. So we have to compute xk cap, which is equal to b cap inverse ak cap. Now xk cap, k is the value where x1 enters. Since x1 enters, this is xk. So k is equal to 1. So from this we have to evaluate x1 cap. So that is equal to b cap inverse a1 cap. So therefore x1 cap will be equal to, what is b cap inverse? We know that it is 1 0 0 0 1 0 0 0 1, the identity matrix. So we shall write that. So b cap inverse is 1 0 0 0 1 0 0 0 1. Next we have to write a1 cap. This a1 cap is, we have to consider this a cap matrix, where this is a1 cap, this is a2 cap, and this is a3 cap. So the A1 cap is this column matrix. So remember, in the matrix A, capital A cap, the first column is A1 cap. So that matrix we have to write here. So it is 2, 1, minus 6. And whenever we multiply two matrices, and if one of the matrix is identity matrix, we get the other matrix as it is. So 2, 1, minus 6 we get as it is. So now after finding x1 cap, so x1 cap, what we have found? We have found x1 cap to be equal to 2, 1, minus 6. So after finding this x1 cap, we will go to step 6, where we have two cases. If all xk cap is lesser than or equal to 0, then there exists an unbounded solution to the LPP. So we have to check whether all the values are lesser than 0. So if we check, only one value is lesser than 0, the other two are positive, it's greater than 0. So we don't have an unbounded solution. The second case is, if at least one xk cap is greater than 0, then find the value of xb cap, which is equal to b cap inverse multiplied with b cap. So if we see, there are two values which is greater than 0. So if at least one value is greater than 0, then we have to proceed to find xb cap. So let us do that. So now in order to find xb cap, we have to first write the b cap inverse matrix. We know that it is the identity matrix 1 0 0 0 1 0 0 0 1. and then matrix B cap, which we found in our first solution. That is, initially we have found what is B cap. We have here B cap is 240, so that we have to take and write here. So 240. So again, when we multiply an identity matrix with a matrix, we get the matrix itself. So 240. So therefore xb cap is equal to 240. So next we will move on to the next step. So that is step 7. We have to write down the results in the revised simplex table and find the minimum of this value. So this I will explain you in the table, and we have to find the key element. So first we shall draw the revised simplex table. So this is the initial revised simplex table. The first column is B. So what is B? The basic variables, that is S1, S2, and then xb cap. Xb cap is what we have got here, that is 240. So 240. And then b cap inverse. B cap inverse, we know that initially it is the identity matrix. So 1 0 0 0 1 0, and then 0 0 1. And x1 cap. X1 cap is we have calculated, that is, we obtained it as 2, 1 minus 6. So let us substitute that. So 2, 1 minus 6. Why x1 cap we have taken? Because we saw that x1 is the x1 enters the basis. So now we have to see which leaves the basis. So for that we have to find the ratio. So what is the ratio? The ratio is xb cap by xk cap whenever xk is greater than 0. So I have written that here. So now we have to find this ratio. For the first column, what is xb cap? It is 2. So 2 divided by xk cap, that is x1 cap here. K is 1. So that is 2. So that is equal to 1. So the first ratio is 1. The second is xb cap is 4 and x1 cap is 1. So 4 by 1, and the ratio is 4. Now since xk cap here is negative, we need not calculate this. So now what we have to do, we have to check out for the minimum of this ratio that we have found. So out of these two values, which is the minimum? 1 is the minimum. So the corresponding S1 leaves the basis. So therefore S1 leaves the basis. So this column is known as key column, and the row from which the variable leaves is called as the key row. So the element corresponding to, that is the which is common to both key column and the key row, is known as the key element. So 2 is the key element over here. So what is the step after this? After finding the key element, we have to convert the key element to unity and all other elements of the key column to 0 and improve the value of B cap inverse. So this is the key column. So this is the key element. We have to convert this key element as unity, that is 1, and make these elements of the key column as 0. So and we have to improve the value of B cap inverse. So we shall write B cap inverse now. So B cap inverse we have to find. So it will be the new revised matrix. So for that, first we have this old matrix, that is we know that this is the old matrix of B cap inverse. So let us take the first row as row 1, second row as row 2, and the third row as row 3. Now we have to change this and find a new matrix where we have to find new row 1, which we will represent as row 1 dash, row 2 dash, and row 3 dash. So we have to find all this row 1 dash, row 2 dash, and row 3 dash. So how we will do that? For that we will make use of this key column. So in key column we want to make the key element as unity, which means we have to divide the row 1 by 2. So if we divide 2 by 2, we will get this as 1. So if we want to make this as 1, the full row we have to divide by 1. So after that, the resulting matrix will give us the first row 1 R1 dash, which we will obtain by dividing the matrix row 1 by 2 in order to make the key element as 1. So if we do so, this first element 1 will be divided by 2, so we will get 1 by 2. So then 0 divided by 2, so it is 0 only, and here also 0, so again 0. So we have obtained row 1 dash. Now we have to obtain row 2 dash. Now remember, this row 2 dash has to be obtained from the row 1 dash that we have recently obtained. So row 2 dash is a new row which is obtained from row 1 dash and making this element as 0 in row 2. Now we want to make this key column R2 as 0 over here. So if we want to make this as 0, what can we do? We can subtract this 1 with this new 1, and this new 1 is in row R1 dash. So 1 minus 1 is 0. So we can make it as R2 minus R1 dash. Okay, so this is after conversion only, this one we got. So R2 minus R1 dash, when we do, we get this. So we have to apply for this row also. So R2 0, R1 dash is 1 by 2, so it will be minus 1 by 2. So 1 minus 0, so it will be 1. And then here we have 0, so 0 minus 0 is 0 only. So next we have to find R3 dash, which will be equal to, now this is R3, so minus 6. So we want to make this as 0. So what we can do, we have 1 here, multiply this 1 by 6 and add it. So minus 6 plus 6 will give us 0, which will make this as 0. So what are we doing actually? R3 and then plus 6 multiplied with R1 dash. So this new one is R1 dash. So 6 multiplied with R1 dash. So same procedure we have to do for other elements. So R3 here we have 0. So 0 plus 6 multiplied with 1 by 2. So 6 multiplied with 1 by 2 is 3. So 0 plus 3 is 3. So then 0 plus 6 into 0, so it will remain 0 only. And then 1 plus 6 into 0, so it will be 1 only. So 301. So we have obtained row 1 dash, row 2 dash, row 3 dash. Patiently go through this, you will surely understand it. So this gives us the updated B cap value, that is B cap inverse value. So after this, we have found B cap inverse. So after completing this, we have to go to step 9. So what does step 9 say? Go to step 5 and repeat the procedure until an optimum basic feasible solution is obtained or there is an indication of an unbounded solution. So we have to go back to step 5. So what is step 5? Step 5 is we have to compute the net evaluation Zj minus Cj by using this. So let us find that. So the next step is to find the net evaluation Zj minus Cj, which is equal to CBB inverse 1 A cap. Already I told you CBB inverse 1 together is the last row of B cap inverse, this matrix. So therefore Zj minus Cj will be equal to 3, 0, 1. So this full matrix is obtained by the last row of B cap inverse multiplied with A cap. A cap is the same matrix that we found first, that is this matrix. So we shall take and write this matrix. So I have taken and I have written the matrix A. So we have to multiply these two matrices and we have to get the value of Zj minus Cj, which is equal to, so after multiplying what I get is I will directly write, so you just check it. For example, this row I will show you. So 3 into 2 is 6, 0 into 1 is 0, 1 into minus 6 is minus 6. So we have to add all that. So 6 minus 6 is 0. Now here if you see 3 into minus 1 is minus 3, this is 0 plus 2, minus 3 plus 2, which is minus 1. In a similar way we have obtained the other 3. So this is by matrix multiplication. So after obtaining Zj minus Cj, we have to repeat the steps that we have. That is, if all Zj minus Cj is greater than or equal to 0, then the current basic feasible solution will be the optimal solution. So if you see all are not 0, we have a negative value. So it's not, first case doesn't apply here. If at least one Zj minus Cj is lesser than 0, find the most negative Zk minus Ck, then the variable xk enters the basis. So if you see, we have one of the value to be negative and this is the most negative value and it is corresponding to x2. So x2 enters the basis. So x2 enters the basis. Now after finding what enters the basis, we have to find what leaves the basis. for which we have to do step 6, that is we have to find xk cap first. So let us find xk cap, which is equal to b cap inverse ak inverse, where this b cap inverse will be the current b cap inverse that we have found. Now since x2 enters the basis, we have to find x2 cap, which is equal to b cap inverse multiplied with a2 cap. And so that is equal to, what is the current b cap inverse that we have obtained? It is this one. So this matrix we have to take and write. So what is A2 cap? A2 cap already I showed you. First we chose A1 cap and now A2 cap minus 1 0 2. So that we have to write here. So minus 1 0 2. Now we have to multiply these two matrices. So that will be equal to 1 by 2 multiplied with minus 1 is minus 1 by 2, and remaining all becomes 0. So it will be minus 1 by 2. And here minus 1 by 2 into minus 1, which will give us 1 by 2, and 1 into 0 is 0, 0 into 2 is 0. So it will be 1 by 2 over here. So 3 into minus 1 is minus 3, 0, and plus 2. Minus 3 plus 2 gives us minus 1. So after this, what we have to do according to the step, if all xk cap is lesser than or equal to 0, then there exists an unbounded solution. But if we see it's not so, this is negative, but here we have a positive value. So all xk cap are not lesser than 0. So now if you see the second case is, if at least one xk is greater than 0, then we have to find the value of xb cap, which is equal to b cap inverse multiplied with b cap. So let us do that. And so that will be equal to, first I will write this b cap inverse matrix, then we have to multiply this with b cap. So b cap is 240, we already saw that, so it will remain the same here also. So it will be 240. Now we have to multiply these two matrices, so that will give us, so 1 by 2 multiplied with 2 is 1, the other things become 0, so it is 1 here, and minus 1 by 2 multiplied with 2 is minus 1, then plus 4, minus 1 plus 4 plus 0. So minus 1 plus 4 is 3. And then 3 2 times is 6. This is 0, this is 0. So we have 6 here. So we obtain 1, 3, 6. Next we have to draw the simplex table again, revise simplex table, in order to find the leaving variable, the variable that leaves the basis, because we saw that x2 enters the basis. So we should know what leaves the basis. So that for that we have to draw a revised simplex table now. So this is the new revised simplex table, where first we have to write the column for basis, then xb cap, b cap inverse, and here since x2 was the variable that enters the basis, we have to write this as x2 cap, and we have to find the ratio. So now what are the bases we have? We know that S1 leaves the basis. So in place of S1, what is replaced? X2 enters the basis. So instead of S1, we have to write this as X2. And here we have to write S2. And now we have to write the column XB in XB cap, which is 1, 3, 6. So 1, 3, 6. And then B cap inverse. So what is B cap inverse? Currently we have this matrix. So this is what B cap inverse we currently had. So that we have to write, that is 1 by 2, 0, 0. And here minus 1 by 2, 1, 0. And then 3, 0, 1. Then x2 cap. x2 cap we have found here. So minus 1 by 2, 1 by 2, minus 1. So minus 1 by 2, then 1 by 2 and minus 1. So now we have to find the ratio. Now in order to calculate the ratio, x2 has to be positive, x2 cap. So it should be greater than 0, but this is negative, so we need not calculate here. Here it is positive, so xb divided by x2 cap. So 3 divided by 1 by 2. So denominator of the denominator becomes the numerator, and 3 will be multiplied with 2, and so we will be getting 6 here. And here also we have negative, so this ratio will also be not calculated. So this is hyphenated. So this is the 1D value we have obtained. So this will be the minimum ratio, and the row corresponding to it is known as key row, and the column corresponding to the key element will be the key column. And so the column, because we know that this is the entering column and this is the leaving variable. So because of this it leaves. So this is the minimum, and so S2 leaves the table and X2 enters. So already we observed that x2 enters. Now we have decided what leaves the table also. This will be the key element, 1 by 2. So we will write here S2 leaves the basis. So now we have to update the b cap inverse value. So in order to update that, what is the previous b cap inverse? This one. So here we will take this as row 1, this is row 2, and this as row 3. And we have to find new matrix for which row 1, row 2, row 3 we have to calculate. So what is the procedure? It is the same. We have to make the key element as 1 and the other elements of the key column as 0. Now in order to make the key element as 1, what can we do with row 2? That we have to check out. We have to divide row 2 by 1 by 2, or we can say that we have to multiply row 2 by 2. Okay, actually this is r1 dash, r2 dash, r3 dash. Okay, new rows that we are going to find. So r2 dash will be equal to, I'm starting with this because that was the key row. So r2 dash will be equal to 2r2. So if we multiply this row by 2, here what we will get, 2 multiplied with minus 1 by 2 will give us minus 1, and 2 multiplied with 1 is 2, and here 2 multiplied with 0 is 0, and 2 multiplied with 1 by 2 will give us 1. So we have obtained this. Now using this new r2 dash, we have to find r1 dash and r3 dash. So now we have to find r1 dash. So for r1 dash, we have to make this element as 0. So if we want to make this element as 0, what operation we can perform with this 1? So here we have minus 1 by 2. If we add plus 1 by 2, it will become 0. So here we have 1. That is the transformed value. So if we multiply this by 1 by 2 and add with this, it will be minus 1 by 2 plus 1 by 2, and so we will get 0. So what are we doing? R1 dash is equal to R1 plus, we are multiplying this by 1 by 2 and then we are adding with it. So if we multiply, that is R2 dash divided by 2. So R1 dash will be R1 plus R2 dash divided by 2. So this operation we have to perform for this to find this row. So R1 dash is equal to R1, that is 1 by 2, plus R2 dash, this is R2 dash by 2. So if we multiply this by 1 by 2, we get minus 1 by 2. So 1 by 2 minus 1 by 2 will give us 0. And this we have to multiply by 1 by 2, it will become 1. Then add with this R1, so it will be 1. So if you multiply with 1 by 2, it is anyway 0, and here also 0. So this will be 0. So next we want to find R3 dash. So to find this row, we want to make this as 0 with the help of R2 dash. So what do you have here? 1. So if you just add these two, it will become 0. So what are we doing? We are adding R3, so this row 3 with row 2 dash. So if we add that, it will be minus 1 plus 1, it will become 0. So when this is made, this operation we have to perform here also throughout. So it will be R3 dash is equal to R3 plus this. So 3 minus 1 is 2. And then 0 plus 2. So that is 2. 1 plus 0. So that is 1. So we have obtained the row R3 dash. So this gives us the current B cap inverse. So after obtaining B cap inverse, what we have to do? We have to compute the net evaluation, Zj minus Cj. So we have to find this. So let us do that. So now this we have to find. So this is equal to, we know that this matrix is the last row of B cap inverse. So we will take that and write. So 2, 2, 1 multiplied with A cap. A cap we already found. That is the first A cap what we found, that only. It is used throughout the same. So this we have to substitute. So A cap I have substituted. We have to multiply these two matrices and we have to obtain Zj minus Cj. So you kindly multiply and check the value. So you multiply and check this value. Now if all Zj minus Cj is positive, we observe that. So if all Zj minus Cj is greater than or equal to 0, then the current basic feasible solution is the optimal solution. So we have to find xb cap. So let us do that. So since all Zj minus Cj is greater than or equal to 0, the current feasible solution is optimal. So now we have to find this xb cap. We have to write the current B cap inverse. So this gives us the current B cap inverse that we have found, and B cap both we have to take in right here and multiply these two so that we can find xb cap. And so when we multiply, what we get? 0 into 2 plus 4 into 1 plus this is 0. So first is 4, and then this is minus 2 plus 8. So it is 6. And then we have 4 plus 8 plus 0. So 4 plus 8 is 12. So we get 4, 6, 12. So first S1 left the bases and X1 entered, then S2 left the bases and X2 also entered, and this will give us the Z value. So therefore X1 will be equal to 4, X2 will be equal to 6. So these are the optimal solution, and the value of Z, max Z, is equal to 12. This you can directly write from this matrix, or you can also substitute in the given LPP. And X3 will be equal to 0. So since we have only x1 and x2, so using this value we know that max z is given by 6x1 minus 2x2 plus 3x3. We can check in this manner also. So when we substitute the values of x1 and x2, what we get: 4 6 times is 24, minus 6 2 times is 12, and this is 0. So 24 minus 12 is 12. Therefore max z is also 12. We have obtained z equal to 12. So x1 is 4, x2 is 6, and x3 is 0. So I hope you would have understood revised simplex method, and these are the computational procedure. So go through it patiently, and step 5 is recursive. So after finding a b cap inverse, we have to recurse and we have to find step 5 until we have to repeat this procedure until we attain an optimum basic feasible solution. Kindly follow the next lecture for more problems under this topic. Thank you.